Hello my dear students, in our last video we discussed about the length contraction. It's about length, and now the similar topic based on the Lorentz transformation equation, and our next topic is the time dilation. Now let us see what is time dilation. See, the time interval between two events in a moving system appears to be increased when observed from stationary system. This phenomenon is known as time dilation. See, in the length contraction we see from a stationary system, the length should be contracted or decreased. But in this time dilation, in reference frame compared to the stationary frame, the time should be more in the reference frame. So consider two frames S1 and S dash here. Imagine a gun placed at a point position x dash y dash z dash. See, x dash y dash z dash in S dash, which is moving with a velocity v. See, velocity v with respect to S along x-axis. Suppose gun fires two shots, is nothing but two times. Suppose gun fires two shots at a frame at a time t dash is first time, t2 dash is second time, measured with respect to S dash. With respect to S dash, the time is t1 dash and t2 dash. Now in S dash, the clock is at rest relative to the observer. So relative to the observer, the clock is at rest. The time interval measured by a clock at rest relative to the observer is called time interval. It's a 1 mark important question. The time interval measured by a clock at rest relative to observer is called time interval. Hence, time interval between the two events for observer in S dash will be t naught equal to t2 dash minus t1 dash. Similarly, like length contraction for S frame, similarly for observer in S frame, measured time interval between two events is t equal to t2 minus t1. It is equation number A, it is equation number B. Now using inverse transformation equations, equation 2 and 3, substitute these two equations in equation number B. The last page we see that equation number B is t equal to t2 minus t1. So after putting these two, Vx divided by c square, Vx by c square is getting cancelled due to this minus, and remaining terms is t2 dash minus t1 dash. The denominator term is same, so we write as same. Similarly, t2 dash minus t1 dash is replaced by equation number A, t2 dash minus t1 dash is equal to t naught. This is equation number A, we know that. So alter this, we get a t naught equal to t into square root of 1 minus v square by c square. That is, t naught is very less than t, or t is very greater than t naught. Using this, we got this. Thus, a moving clock goes slower by the factor this. In the length contraction, we see that by the same factor, the length got contracted. By this factor, the time goes slower. Cases, see, there are different cases in here as compared with the speed of that object. At low speed is nothing but velocity is very less than c. Then v square by c square is neglected. Then t naught equal to t. This term get neglected and t naught equal to t. When v is a little bit less than c, then square root of 1 minus v square by c square term is less than 1. That time less than 1 means minus value, so that time t naught is very less than t. But when the velocity is equal to the speed of light c, then this whole term becomes 0, then t naught is equal to 0. Anything multiplied by 0 is becomes 0, right? So t naught is equal to 0. Now when the s dash frame moves with an velocity c, the time will be stopped. Once again, when s dash moves greater than the velocity of c, what happens? The time will be negative. The time will be negative. On this time dilation, we explain two important terms. Those are called illustration for time dilation, and our exam point of view, these two are very important. See, this one is, first one is time paradox. Consider two exactly identical twin brothers. Let one of them twin go to the along space journey at a high speed in a rocket, and the other stay behind on the earth. Consider two exactly identical twin brothers. One is go along a space journey in rocket, high speed rocket, and another one stays at the earth. The clock in the moving rocket, it will be appear go slower than the clock on the surface of the earth. According to the relation, by this relation, therefore, when he returns to the earth, he will be find himself younger than the twin who stayed behind on the earth. And now the second one, mu meson decay. First illustration is time paradox, and second illustration is mu meson decay. A mu meson which is at rest, see, a mu meson which is at rest is decays into an electrons. Mu meson at rest, it decays into electron in 2 into 10 to the power of minus 6 seconds. That is, meson's mean lifetime is 2 into 10 raised to minus 6 seconds. This is mean time of mu meson. This is at rest, okay. Now mu meson are also created in the atmosphere by fast cosmic rays. See, these mu mesons also created in a atmospheric by fast cosmic rays. Here the mu mesons are rest, but here the same mu mesons are at some velocity and reaches the earth surface with high velocity about 0.998 c, almost equal to c, right? If t naught is equal to 2 into 10 raised to minus 6 seconds and velocity is equal to 0.998 c, then because of this velocity, there will be decay in the decaying of mu mesons. There will be delay in decaying of mu mesons, or the half lifetime of mu mesons becomes more than the t naught. Time dilation, right? Time slow agutte. We know that time dilation is nothing but time becomes slow. Here is in this speed, when the same mu mesons are moving at high velocity, this time will get slower, and that slower time is given by t equal to t naught divided by, we know that relation is right. Substitute these values, we get t is very greater than t naught. See, 31.7 into 10 raised to minus 6 per second. This is illustrations of time dilation. First one is twin paradox and mu mesons decay. And this is about time dilation and illustrations of time dilation. We continue in our next video.